Now, starting with today's webinar, I would like to request Director ICAT, Shri Saurabh Dalela, to deliver the welcome address.
Good morning. Am I audible?
Yes, sir.
And am I visible?
Sir. Yes, sir, you're visible now.
Great.
Good morning, sir.
Good morning, everyone. I can't see many people over here. So anyways, I can see Mr. Shrikant Rao now. Great. Mr. Jitendra Khare.
Good morning, sir. Good morning.
Distinguished guests, Mr. Jitendra Khare, Associate Vice President and Head R&D Krishnamaruti Limited. Shri Shrikant Rao, Senior Principal Engineer, Interiors, Goodrich Aerospace. Shri Chaitanya Reddy, AGM, Corporate R&D, Aizen Automotive, and Shri Atsushi Abaka, Global Regulation Specialist, Aizen Automotive. This is a great pleasure and privilege that I'm connected to all the distinguished speakers and distinguished people over here. And this is also a great opportunity for all of us, wherein we can discuss about automotive and non-automotive seats. ICAT has always been doing seminars where not many people are present. For example, very recently we did our seminar on lighting, automotive lighting, which again is a very, very limited kind of a seminar that we do, and there are very limited seminars across the globe who are working and doing some work towards automotive lighting. Similarly, this particular subject is seats, which not many people are talking, but it is very important because this is directly connected to road safety, because the worse the seat, the more is the fatigue, and more the fatigue, more the accidents, and driver drowsiness and driver fatigue, and all this is connected. So not many people are talking about it, which gives us an excellent opportunity to discuss and deliberate upon these areas. Now, ICAT has taken this initiative to organize webinars, seminars, awareness programs in various domains of automotive technologies, and this being one, as I said, just to provide a common platform for knowledge and exchange of knowledge, as well as to support the automotive industry, including the OEMs, the component manufacturers, and academic institutes. It may be recalled that the origin of ICAT has been very clearly mentioned, that we are going to be the center of excellence for components, and this is one of them. And I'm very happy to see all of you here, and I'm very happy to be connected to all of you in talking about this very important subject. Now, coming to this particular subject, this is, as I said, is a great opportunity. But then in the past few years, there has been a tremendous growth in the Indian automotive sector, along with focus on R&D, innovation, and a lot has been talked about the fact that India is going to be the world leader in the days to come. We are envisaging our third spot in the world after China and US by 2030. And we are also talking about a lot of road safety issues, and this makes this subject therefore very, very vital and important. Automotive seat market in India has been growing at a steady pace, and the growth expected to accelerate in the coming years is due to continually rising vehicle production and sales, which is being mentioned by the government of India. Also, it will be accelerated further when the scrappage policy comes in, and the policies which have been launched by the government related to scrapping and recycling, that's Chakrita, that all comes into a picture. This will further enhance. The global automotive seat market in terms of revenue was estimated to be about 51.5 billion, in 2022, and this is poised to be 68.4 by 2030, which gives it a CAGR of 3.2%. And it is still the future, and the autonomous cars finally are going to be there, and this will give us a real chance or an opportunity to change the way the seats are. The vehicles that not require the attention and involvement of a driver will become mobile, transform living rooms, bedrooms, and even conference rooms. For example, we are talking about caravans. There is a recent standard which has come, and the world has been always using caravans. India will progress into this area, and this is again a great opportunity for all of us. So seat is no longer, the seat that we imagine in a car that, okay, driver is going to sit, the co-passenger is going to sit. It's much beyond now, and it's getting more smarter and more intelligent as we speak. It's a component which is being seen with the varied changes in technological advancements in terms of features like reconfigurable seats, heated seats, ventilated seats, seats with massage features, intelligent seats which use sensors in cars to reposition seats and avoid a damaging impact in case of a crash. Detect the physical and mental well-being of a driver and passengers, or alert occupants on a medical emergency. So these are the very key roles and vital roles which seats are right now playing a very important role. I'm also glad to share with you that under the Atmanirbhar Bharat campaign of our Honorable Prime Minister, Ministry of Heavy Industries has assigned ICAT the task of creating a technology portal for facilitating the Indian automotive industry to become self-reliant by promoting innovation and adoption of global standards. So with this, I'm very happy that I'm connected to all of you, and I wish this seminar to be a great success. ICAT has launched an e-portal, Aspire, which I think most of you are aware on, and I hope the seating industry will utilize this opportunity, which is being opened now, in order to exchange their technical expertise, knowledge in terms of helping the country in its economic endeavors and also in safety. So in conclusion, I would like to thank each one of you for joining this very important webinar and enriching and inspiring your experience and knowledge. And I look forward for a very insightful discussion, meaningful discussion, collaborative discussion in the day to come. So thank you very much for being with us, and thank you very much for making this a very successful initiative of ICAT. Welcome to this event once again. Thank you very much. Let's see this going forward. Thank you.
Thank you, Saurabh.
So much for your motivational words, sir. Today, we will have 4 technical presentations by various industry experts. For the first presentation of the day, which is on the topic Futuristic Advancements, Challenges, New and Upcoming Technologies Related to Seats, I would like to invite and introduce Shri Jitendra Khare. Shri Jitendra Khare is a techno-commercial mentor and Associate Vice President, Head R&D, Marketing, and responsible for KML seating account size 2.4 billion financial year 22-23. His major career journey is with DRDO, JCI Indian, EU operations, and now with KML seating with 10 plus global patents and design certificates, driving the innovation since past 25 years in engineering, product management, greenfield automotive seating plant, product strategy, design and development of complete seat PV and CV lifecycle, mechatronics, activation devices, metal and plastic structures, complete seating, interiors, mechanism latches, HA, tracks, recliners, localization, sourcing of automotive industry. We welcome you, sir. You may start with your presentation now.
Thank you very much for having me here. I hope I am audible and my screen is
sir.
visible to all.
Yes, sir.
So today is a very interesting subject as we are growing. So if you will see the data, it shows that post-COVID, the mobility and personal mobility is the essential part. It was earlier the essential part, there's no doubt, but after COVID era, it has become the essential and more, people want to have their own vehicle, sir? Whether it's two-wheeler. Sorry.
Sir, sorry for intervention. Can you please switch off the presenter mode and do your screen in full screen?
Is it visible now?
Yes, sir.
Yeah. So going forward, it is whether it's a two-wheeler, three-wheeler, four-wheeler, or any non-automotive like aircraft, seating is the essential part, right? And the drive which we are in right now, it is mainly driven by the Make in India concept. So let us have some data which shows that how the this is the we have to act like how we can sell it whether car is our essential part. Earlier we can say no, but now everybody want to have it, whether it's two-wheeler or four-wheeler, right? And similarly, when we call about the the transportation system, everybody knows like it is creating a pollution. So we have a lot of technology like throttle, diesel, CNC, bio-CNG, hydrogen is also evolving, EV, IC, hybrid, hydrogen, it's all are coming into the pictures. And at the same time, when roads conditions are improving, you can see like earlier traveling small distance also we are taking more time, but the way we are improving our infrastructure and core focus of the present government is also going in a big way, and we can see the result in the ground also, that how we are improving our road condition. So definitely speed limit is also increasing on our highways, expressways. The speed is directly connected with accident. Is it true? So that is also we are going to discuss today with the data, which is a little bit surprising. So this is the global trend, that how we are thinking, moving forward for the sustainable development scenario. And when we are talking about this, it's like a balancing act. What we can do so that we can manage the show. We have to manage our growth. We have to manage our aspiration. At the same time, we have to care about our environment also. So there are a lot of technology like BCS, DAC, which is right now under the you can say the pilot stage, but it is going to be the reality very soon, because without that it is not going to be the balancing act. Some more numbers, like you can see the sales of automobiles, whether it's a two-wheeler, passenger, commercial, three-wheelers, we are in the increasing trend, right? So that means what? Are we going to compromise on the volume, or are we compromising with the environment? So both the things are necessity now. And you take whatever segment you have, but you need the seating system, right? So seating is the critical part of our ecosystem, which is directly related with the occupant. So let us start with the basic. what is the main purpose of the seating system? So what I assume and understand, it is the system which is there to support to occupants ergonomically and all condition inside the vehicle. When we talk about all condition, it is very vast area, starting from the routine condition till crash, right? So when we talk about the scenario for the development, that we understand that it's a changing environment, VUCA, and change is the only reality. So if we talk in terms of makers and customer, both have their own selection system. Or if you talk about the maker, they have to consider the safety, which is the critical aspect, because this is the seating system is directly holding the live person. Legal compliances on which continuously new rules and regulations are coming, whether they are practical or they need some more improvement. This is how the continuous improvement is going on. Future regulations which are under consideration right now, passive and active controls and their supply chain. So these are the key aspects for the makers looking at the VUCA environment. At the same time, the customer is more willing now and have the major option, because all the big giants are here. You name it, and they are here in India. Whether they are completely manufacturing in India or they are doing the KD assembly, but they are there. Their presence is there because we are the very big market, and proud to say #1 in the population now. Our millennial is almost 30-34%. So the big aspiration for all the giants. This is why they are here. So their priorities are different. They need comfort, feature, styling, craftsmanship, environment, which has become the big topic of today's scenario, fuel economy, brand, at the same time price tag. So these are the factors which is there for the customer. But ultimately, makers are making the systems so that customer can buy it. And when we are saying that, these all 5 points which are related to the customer are the driving factor backward. So the controlling act is the key. But when we talk about how to manage the soap, because at the bottom, everybody want to go with the brand, whether it's Indian MNC or global MNC, they want to have the brand, they want to have the feature, they want to have the styling. At the same time, they want to have the good price tag, because the competition is, there. So let us talk about the seating system. So how we can, manage the soap which is sellable to the customer. So when we have done analysis and we have this data that 50 to 70% weight of the metal is participating total weight of the seating system. So let us say if 100 kg is the weight, 50-70% kg is of metal. So we have a big area where we can target. And second point, which is critical, which can be directly integrated with the price tag without compromise on the safety and regulations, that is import. So still 15 to 20% bomb size is imported as on today. So this is some graphs which shows like how this is related. When we are minimizing the weight, we are increasing the cost. If we are increasing the weight, how the fuel economy is behaving, and as the road conditions are getting great in our country, how the the economy of our transportation system is behaving. So when we go into the detail, there are mechanism, sheet metal, plastic, composite, then module and seats, right? So here, the biggest point which I want to make, how we can make our SWR high, means lowest possible weight, because that will drive the economy, that will drive the BOM size and localization of the commodity maximum. Then only we can achieve the FSSP, which is the customer voice as of today. And I assume that will remain forever. So when we are going more in detail, what we know, like in metal, most of the companies right now, they are already moving toward the high strength steel. Yeah. So here all the 4 quadrant, moreover, our make in India and availability in India by Indian companies are very good. And welding technology or joining technology is also moreover indigenized. But to make the SWR in better aspect, can we go for the composite, which is very good, solution. But at the same time, when you will see the 4 metrics, the material, machines are imported. Methods are not very much compatible for the mass production which we need. Yes, manpower we have. So this is the area when we call about the challenges, the opportunity also pop up. Like Modi San also told, जहाँ पर प्रॉब्लम है वहीं पे आपको अपॉर्चुनिटी है. So it is the big area where together with the Indian companies, we have to do a lot of R&D, because we know the theoretically that what all the composition and all, but due to the low penetration, the localization is a big issue in this area. So as on today, we can say it is not so mature, but this is a big opportunity, because right now when it is imported, cost is also high, but when it will become Indian, definitely cost will come down and it will be better for the strength weight ratio, which is the advantage for the consumer. Same thing for plastic. So when we are doing this analysis, which is very much integral part of our BOM, still we have a lot of raw material which is coming from outside, because Indian RM is costlier and most of the R&D is happening outside India. I don't want to name it, but in core designing, people were reluctant to invest in India, but right now the scenario is changing after a big push from the government. Same thing with PU or foam, which is the essential part. Yeah, we are making the molds, machines, which are not very much advanced, but material again it is coming from outside. Yeah, so here also we have a lot of dependency, which is affecting our supply chain. So lot of challenges, but at the same time, lot of opportunities also, right? Same thing for the safety module and their components. So most of the safety modules, if you will see, the critical components are coming, we are importing, and second level assembly and sub assembly we are doing it in India, which is another opportunity for us to grow further. Electronics, anyway, our government is looking very seriously, and they have started one incentive program. So this will change the complete supply chain, and which will be big advantage for India to drive the future. So what are the features and why we need that? So if you will know, it's a common sense. Like earlier when we started in the 80s, to have the four-wheeler or two-wheeler was the pride. It was the status symbol. But now it is not a status symbol, it's a reality. It's a necessity. So now next what? So like connected cars, ventilation, power, memory seats, thigh support, massager, feather dynamics, bolster adjustment, flipping of the seat in any direction to have the chat when the new advanced automated vehicle will be on the road. So these all the new technology which are, you can see some of them are going to be the integrated already in the most of the OEM, definitely at the highest variant, and some are under consideration in the advanced development. So they will become the reality, and all it is driven by the the customer choice, because they have a good entry level salaries, business oriented environment is increasing, easy loan is available. So everybody want to have the feature, provided they have the enough backend support. So this is how the industry is changing. And apart from the technical stuff, which as a technical way we know the supply chain regulations, but customer need the styling, price tag, so many features, craftsmanship, and lot of luxurious item apart from the lot of electronics, so that they can enjoy the ride. And that is how the industry also moving. In KML, we all are trying to be doing it in-house, whether it's proto building, CAD modeling, new stuff, new technology, component engineering, FEA, in-house testing, and different conceptualization for the SPM and assembly lines. Our core motive is how we can indigenize a lot of things for the product, for the processes, and driving the dream of Make in India. So thank you very much. Any query, I will be happy to answer.
Thank you so much for excellent presentation, sir. We will take questions during the end of today's webinars.
Okay. Thank you.
Moving on to the second presentation on the topic of global trend in seatbelt reminder for passenger safety impact for India, I would like to invite and introduce Sri Chaitanya Reddy. Krishna Chaitanya Reddy is a seasoned professional with extensive 18-year tenure at ASEAN India, a leading automotive component manufacturer. He holds the position of head of corporate R&D department, where he oversees strategic research, product validation, material engineering, and regulatory activities. He has a post-graduation in tool design from NTTF and Bachelor of Technology in Mechanical Engineering from JNTU. He leads a diverse team of engineers, researchers, and experts, guiding them to achieve key objectives and deliver innovative solutions to the automotive industry. We welcome you, sir. You can now start with your presentation.
Thank you very much, Devyani. I'm going to share my screen. Hope everyone is able to see my screen. So good morning, everyone. Firstly, I would like to thank ICAT for the opportunity given to ISIN to participate in this webinar. So we believe such kind of knowledge sharing is very key for faster development of automotive industry in India. The topic that I'll be talking today is about the global trend in seatbelt reminder for passenger safety and the impact for India. So I will be presenting the agenda in the following way. So we start with a small introduction of ISIN, and then we just have an understanding of why exactly the seatbelt reminder is required and how it works. And then we will have a short glance on the NCAP status globally and the trend of occupant detection areas. Further, my colleague who will be joining from Japan, Mr. Abaka, will be giving us a visibility on the global trends in the domain of occupant detection and the areas to future focus. Finally, I would like to stress upon a few areas of accident data that is very important for future development for occupant detections and also safety of the passengers. Okay. So firstly, going ahead, I would like to first introduce about ISIN. So ISIN is a company headquartered in Japan, and which was incorporated in 1965. Presently, it has about 207 companies worldwide and a Fortune 500 company. We are having a diverse product range and solutions, but its primary focus is in making the mobility more safer. So we have been having an experience with global OEMs by catering to their needs and requirements. Okay. So coming down to the main agenda of today. So why is a seatbelt reminder required? So I think most of us already know that wearing of seatbelts reduces risk of fatality during an accident. It reduces the risk of fatality by almost 50% in the front and 25% in the rear. This is as per the World Health Organization. But coming down to India, this pie chart, which I've this pie chart, which is visible over here, shows that a research in the Indian domain from the same WHO says that about 90% of the seats of the passengers are actually highly unwilling and have very low awareness related to the seat belt reminders or seat belts wearing in the vehicle. So as we are speaking, in the last 1 hour, there were almost 2 to 3 fatalities in the road in India, which is related to the not wearing of seatbelt in the vehicle. So this calls for a need for reminding the occupants of wearing a seatbelt. So one of the methods that we can see is enforcement. So wherein, just like an air hostess in an aircraft ensures all the passengers are buckled up. So in fact, this type of seatbelt is called a lap type seatbelt. The requirement for this is more because that whenever there is a air travel, so we have the air turbulence actually causes a vertical movement wherein the passengers, whenever there's a turbulence, the passengers tend to move on a vertical side. And if at all there is no seatbelt worn, the passenger hits onto the luggage room on the top, which is placed on the top side of the aircraft. And there is a chance of high rate of injury and also fatality. So because it's an aircraft and a very limited range of people, a few hundreds, air hostesses ensure that they enforce each and every passenger to wear a seatbelt. But what happens when there is an enforcement to be done across very big number of people or areas, which crosses more than thousands or in the normal general roads? So there comes the next method of regulation or rule. So For example, it is really practically not possible for any person, any policeman, or any government to make 100% enforcement across all the vehicles that have been moving on the roads and check that each and every passenger inside the vehicle are belted or buckled. So that's where the seatbelt reminder comes into picture. But let's see what exactly happens when there is an impact on the vehicle when the person is not actually wearing a seatbelt. So whenever the person or the occupants are not wearing a seatbelt, especially the rear seatbelt, if it is not worn, it is not only fatal for the rear seat passenger, but also the front seat passenger, even though when he is wearing a seat belt and we have a safety provision of an airbag, because of the impact of the rear passengers crushing onto the front passenger, both of them are at risk, and they tend to have a high level of injury, and also it might lead to a fatality. But of course, when you want each and every passenger to wear a seat belt, penalizing is one of the aspects, and it might increase the rate for a little bit. But a simple reminder inside a vehicle which reminds each and every passenger to wear a seat belt by way of alarm, it will be very practically useful. And for example, when you say a person is belted on the rear side, we can just continue to see the video of how exactly the impact goes on. So here, this seat belt restrains the rear passenger not to move on to the front passenger, and it avoids the collision onto him by saving both front and the rear passengers. So coming down, there is a research in and the statistics by Quanson Research, which has been done in 2020. It says that the wearing rate, it has a comparison with the wearing rate and the seatbelt reminder usage. So when there is a seatbelt reminder only with a visual warning inside a cluster or a dashboard, which is visible only to the driver, the wearing rate is around 56%. But when it is visible for all the passengers across all the seats, then the wearing rate goes on to 72%. But when there is a visual and the audio warning, which is audible or visible to all the passengers in the vehicle, the rate of wearing in the rear passengers goes on to a staggering 97%. So this is a very important fact where seatbelt reminders actually have a very good impact in the increasing the wearing rate of the seat belts. But when you coming down to India, this data is basically a little bit older data of 2018-19, wherein the rate of seat belts in India for the front side is maximum 40% in the front and 11% in the rear. But when you come down to India, where there is enforcement is very low. I'm not talking about because we are not capable of. It is because of due to the diversified geopolitical situation and geographical location that the enforcement is not practically possible in each and every corner of the country. There is a requirement of a seatbelt reminder. So I can just end up this particular slide saying that whenever there is whenever the enforcement cannot reach the end user, there is a requirement that the product, in this case a car, has to satisfy that particular need with the use of regulation. So going down to the next point that I want to discuss upon is about how a seatbelt reminder works. So basically a normal type of seatbelt reminder checks the status of the seat buckles. In fact, there is a sensor inside the seatbelt buckle, and it is installed on each and every seat. And whenever it senses that the buckle is open or not, it's not buckled, and the IG is on, and it goes on for a stipulated speed, say around 20 to 25 kilometers. So it automatically gives a warning at this point of time, present situation. It says it gives a visual warning and also an audible warning. And it reminds the seatbelt passengers that they are not belted till the point of time the belt is buckled in for each and every seat. So, and then another feature, another type of seatbelt is basically with an occupant detection. So here, the type of seat belt actually senses the occupancy of each seat. So whenever the person is seating in this seat, so there will be a pressure sensors inside the seat cushion. It is something called a film sensor, and the number of seats, number of pressure sensors compressed when a passenger seats on the vehicle understands that a occupant is sitting in this particular seat, and it gives an alarm if at all the buckle is open. So this also has the same feature whenever there is an IG on and this is and the stipulated number of speed is reached and the person is occupying a seat, then the alarm goes on. So both of them are seatbelt reminder, but the later one is occupant detection, actually detects a person if he is sitting in the vehicle or not. So how exactly the impact for the seatbelt wearing rate is there in these two types is that the earlier one, where we call it as a normal seatbelt reminder, basically has a tendency where each and every time a passenger or a driver boards a vehicle, he has to listen to the warning for the minimum of 60 minutes, even though the rear passenger is seated or not. So this way, what happens, what is the tendency that globally happens is that the passenger or the driver, whenever they are sitting, gets irritated and looks for an aftermarket solution to cancel this particular alarm. So he either pulls off the wiring or he has to use an aftermarket solution where a clips, which has been sold in Amazon or any other location, is being used to cancel this one, and he forgets on that. And basically what happens is whenever he reuses a car with the rear passengers, there is no alarm, and there is a high chance that the rear passenger, if he meets with an accident, meets with a fatality or a high range of injury. So our purpose of increasing the seat belt wearing rate will not be directly possible with this particular technology. But when there is an occupant detection, what it ensures is that it gradually changes the mindset of the people so that they tend to wear the seat belt. So whenever there is a person seated in specific seat, only that particular specific seat gets a visual highlighting and a alarm warning, and it gives an alarm so that the driver or the passenger, he himself, realizes that he has to wear a seat belt. So coming to the global status of the NCAP, so how this technology has been adopted globally is seen over here. Here we see the global situation with respect to seat belt wearing rate in the front and the rear. This is highlighted in the pink as per ResearchGate. So the wearing rate, as you see, is high in Europe and also Australia, both in the front and the rear. These both regions actually have adopted the ODS, as an abbreviation says, occupant detection system, way back in 2009 through NCAP route, so that the vehicles which targets higher rating, star rating, will have an ODS as a feature. Presently, the ODS is a prerequisite for getting any star rating in Europe or Australia, while USA is also having a high rate of seatbelt wearing rate, but they do not have an option that has been adopted in the NCAP, it's called NHTSA. The seatbelt wearing rate is high due to the kind of enforcement that has been done in the United States. I think many of us might have known or experienced the situation of how a person gets a driving license in USA and how stringent their methodologies are. So it's more about the awareness in the country which instigates the wearing of seatbelt, and the rate of wearing is really very high. But Korea and Japan and Malaysia do have a very good wearing rate in the front, where it's around 96% or more of 86% in the passenger side, but they have a comparatively lower wearing rate in the rear. So this is where we can see that the adoption of seat occupant detection or the seat belt reminder in the end caps was not promoted yet. So, but we can see that China and Malaysia have actually implemented the occupant detection recently, when China has implemented in 2015 and Malaysia has implemented in 2021. So there is a gradual increase that we can see, we expect to see in coming days, where the seatbelt wearing rate will be visible. But coming to India, this is a 2017 data wherein the values are very low, but the recent regulation and the impact of the accident, famous accident that we have all aware of, has given a little bit of consciousness and awareness to all the passengers of the vehicle, which is instigating them to wear the seat belts, and also the recent regulations and the enforcement directives taken by the government of India. We might be seeing a good rate of increase in seat belt reminders. And yes, coming back to the NCAP, so a protocol for the NCAP rating is yet to be formalized, and in fact, this is in the under discussion stage. But when we clearly see, we can see clearly over here that regions that have implemented, especially the Europe and Australia, who have implemented the occupant detection area technology at an early stage through NCAP, have a very high seatbelt wearing rate. When there is a low wearing rate in the other countries, it means that adoption inside NCAP is very good, has a very positive impact in the seatbelt wearing rate of each vehicle. So as a conclusion to this particular slide, I could say that NCAP needs to be effectively used to introduce latest technologies which will make mobility safer. Now, I would pass on the mic to the Devyani, so that she can introduce Mr. Abaka, who will be speaking about the global trend of occupant detection. Over to you, Devyani.
Thank you, sir. Now I will introduce Mr. Atsushi Abaka. Mr. Atsushi Abaka has worked for ASIN, a leading Japanese auto parts manufacturer, for 15 years. He has been involved in the design and development of seat frames in the initial 10 years, and is a professional who has learned the knowledge of seat collision and safety. For later 5 years, he has been involved in the design and development of seat sensors and surveys of regulation and assessment in major regions around the world, and is a professional in collision safety and preventive safety. We welcome you, sir. You may start with the presentation now.
Yes.
Okay, is my presentation still visible?
Sir.
Okay, I'm sure.
Yes, it is visible now.
Thank you. Good morning, everyone. My name is Atsushi Abaka, and I am handling global regulation for collision safety and passive safety technologies for ICAT. This page will be explained by me. On this page, I will explain global technology trend for occupant detection. At the top of the page, you can see the trend of detection technology and the trend of loop. At the bottom of the page, you can find product examples of collision safety or prevent safety related to trends. The purpose is described in yellow background. Technology trends. Starting from occupant detection and physical detection. In recent years, there has been a trend toward biological detection and face detection is called face recognition or personal recognition. In rule trends, from XPR regulation and assessment aimed at reducing fatal accidents at the time of collision. it will be pro establishment of rules for the purpose of protecting passengers, not limited to collisions. Actual product example and its purpose are described. An example of a front sheet is shown at the top. An example of a rear sheet is shown at the bottom. This is the first explanation. This is common to the front sheet and rear sheet. The technology is occupant detection. The technology of warning is issued for the purpose of increasing belt wearing rate. Actual product example is thin film sensor, as shown here. Second explanation, the technology is physical detection. Controls the deployment of the airbag for the purpose of reduce harm of airbag deployment. Example of actual products are shown here. Weight sensor or capacitance sensor or gel mass sensor. This is the third explanation. This is primary for drivers. The technology is facial detection. Alert for the purpose of prevent drawings. An example of our actual product is a camera, as described here. This is the fourth explanation. The technology is biological detection. The technology is it provides armed and ready for the purpose of prevent hot car disease of child. Actual product example is radio wave sensor or millimeter wave sensor or camera. Please, back page. Wait, please back page. Judging, yeah? Okay, thank you.
Okay, thank you, Abaka-san. So, thank you very much, Mr. Abaka-san. So, as you see, like as Mr. Abaka-san has explained, these are the areas that global technology trends in occupant detection are there, and ICAT is already having multiple developments being done in these areas to make, especially targeting mobility to be made safer. And another technology that has been introduced by Abaka-san is about radio and millimeter wave sensor, whereas a sensor is being used to detect the presence of the child. And this particular technology is basically adopted in uniquely for American market, wherein a lot of hot car deaths, it's called, where child is being left out in the car and while the parents or the user are shopping or etc. So there are a lot of hot car deaths happening. I mean, almost 60 to 70 deaths that we can see. So it has been very unique for American market. So that's where they've been adopting this particular technology. Coming down, I think when you see the Indian scenario, I think these sort of researchers, this sort of analysis or data analysis, very much important for future developments of technologies targeting to reduce the fatalities in the accidents. So that's what is my next topic of accident about accident-related data. So I think my dear friend Mr. Kare also has suggested that the number of accidents in India are very high, and to have a more specific data, this particular data is again from the WHO, wherein we say that India has the leading number of road fatalities per lakh of population. It's almost 20 numbers dying every lakh of people, and followed by US and then Korea. but the yearly number of road fatalities, it is way more higher than anyone can imagine. I think it's around 150,000 fatalities in the road. And when you come down to the actual four-wheelers that we're talking about, where we actually are concentrating on is around 13%. So it comes to around 23,000 deaths or fatalities that we'll have to concentrate or target to reduce on. So of course, everyone is aware that Indian government is very closely seeing on this particular developments and is targeting around 50% reduction by 2030. So as part of which, of course, the reason for that is unfortunately or fortunately, India is a very young nation, and the fatalities unfortunately hit us really very hard. So whatever fatalities I'm talking about here is 150,000, out of which 70% of the people are in the age range of 25 to 45, which is actually the income earning stage. So the government realized that the socio-economic impact on the government is around, for each fatality is around 90 lakh rupees, and which goes on from the right from the death, right from the birth of the person till the point of time is capable of earning. The government spends on a lot of medicals, educational and society related areas that government actually spends on each citizen. So when you multiply that with the number of fatalities each year, it goes to a staggering 140,000 crores that we are losing every year, and this actually has an impact on the GDP. This particular information is from the MRTH. So for which government has initiated a drives, very, very stringent drives that has been conducted. In fact, ICAT also is involved in a lot of formulations of that. So as a phase one, we understand that there is a global harmonization that's going to go up, where a lot of implementation which has been happening globally as a base for ABS, airbag, SBRS, driver monitoring systems, and we are coming to see autonomous emergency braking, forward collision warnings. All these things will be implemented or harmonized by 2025. And going down as a phase two is what we see is this area that I feel or we feel that we will be requiring an Indian specific standard criteria or regulations. So going down, this is about some of the information, that is a roadmap that we've been following up, where a lot of regulations have been implemented in terms of connected, autonomous, and safety. Safety is a number of regulations that has been coming up, and it's been harmonized by 2024. I think we can have a harmonized situation where we'll be at par with the global standards of safety. But seeing the number of figures of road fatalities, we feel that there is a requirement of Indian specific requirement or analysis that has to be done. So there is a need of strong analysis of accident data, and this requires, as I think Mr. Kareswan also has stressed upon, is a lot of research that has to be going into this particular area, wherein universities and of course we need to have a joint researchers so that auto companies also can contribute on that analysis to make it more streamlined approach to reduce the fatalities. So there is a need to initiate global methodologies for making specific accident data acquisition to target technology required for India. As an example, as a very simple example, I just wanted to have few highlights which have been, which we have compared with what has been done in Japan and what is that India doesn't have. So these are the few examples that where we see. And it is specific to seat belt reminders and seat belt related wearing rate. So number one is that the fatalities by seat belt wearing status. So each status in Japan, we have how many number of persons who met with an accident or has a fatality in an accident. We have an analysis, we have figures or percentages showing that who is wearing seat belt, who was not wearing seat belt. But unfortunately, in India, we have a gradual decrease in this particular seatbelt, who have not been using seatbelt. But over a period of time, we will be requiring data which shows that how many number of people are having a fatality when actually wearing a seatbelt also. So this will actually be for the future technologies that we are talking about. So this analysis is very much required for us to target on what has to be adopted in the next technology to control the fatality rate. And the second one is a nationwide survey that Japan generally conducts in seatbelt wearing status. So it actually conducts survey at specified predefined locations and gives us a rate every year that how much is the rate of wearing in the front passenger and the rear passenger. But in India, we do depend on some sort of a display from the World Health Organization or so. But as a country, we do not have a database on this particular area. So this actually has a very big impact and effectiveness of each technology. For example, we are going to implement or already implemented the seatbelt reminder technology or regulation. But after 2 to 3 years, we would like to see the impact of that. So we should be having that particular data. So I think that particular area needs to be instigated from the government side as well. And then on this, as a third point, is like the rate of seatbelt wearers by seat among fatalities while riding in a car. So each specific seat has to have an analysis, like front passenger, rear passenger, or front right passenger, left passenger. So with respect to the degree of injuries that is facing in each range, each seats. So this again will be very much useful in developing solutions with respect to reducing the fatalities. So this is what I'm trying to take for the future, not for the existing situation. But existing, I understand that India is very much concentrating on increasing the seatbelt wearing rate. But we have already taken actions related to those, like introducing of regulations and enforcement and penalties for that. So we foresee that in next 2 to 3 years, we will be seeing a higher rate of seatbelt wearing. Maybe I'm hoping it reaches 90% in at least 2 to 3 years. So once it reaches, I think we still will be having a different type of fatalities or different type of fatalities in the road accidents. So to counter those areas, I think we will be having this particular data as a base to take it up further. So as a conclusion and a way forward, I would like to make 3 statements wherein the NCAP needs to be effectively used to introduce latest technologies which will make mobility more safer, and technology adoption for occupant detection and classification to make mobility safer, just like the radar and sensing situation that has been used in USA. For some specific areas, I think these particular technologies have to be inculcated into Indian automotive domain as well to make our cars or our situations more safer. And finally, there is a need to immediately initiate and adopt government methodologies and specific methodologies for accident data acquisition to target technology development required for India. Thank you very much. So I'm open for any questions, or I'm just handing over the control to Devyani.
Thank you so much, both of you, for the excellent presentation. We don't have any question as of now. If we have any question in the future, we'll forward them to you. We will now have the third presentation of the day on the topic of regulatory requirements and ICAT's test facility for seats. For that, I would like to invite Mr. Rohit Tripathi, Assistant Manager ICAT, on dais.
Good morning, everyone. Rohit Tripathi this side. Welcome you all for this session, facilities of seats and introduction about ICAT. So here at ICAT, we have 3 centers, as you can see, 2 centers, sorry, Center 1 and Center 2. So ICAT International Center for Automotive Technology It was established in 2006 in Manesar, Haryana. We have 2 centers and human resource capacity of around 535 plus. ICAT has been the center of excellence for 4 units: powertrain, MVH, component, tire and wheel. So here is the organogram how ICAT exists in this ecosystem. So ICAT is under National Automotive Board, NAB, which is under the parent Ministry of Heavy Industries. So the approximate investment from the Government of India, Ministry of Heavy Industries on ICAT is approximately 1260 crores. Coming to the authorization and accreditations that ICAT holds. So ICAT has been authorized by CMVR, the MORTH, Government of India, for type approval and the COP of various components and the vehicles, and also for CTCB by CTCB for emission and noise type approval and COP for generator sets. Now coming to the accreditation status of ICAT. ICAT is accredited by, its facility is accredited by NADL ISO 17025 and by VCI UK since 2008 for all the testing facility related to the export homologations. We have been accredited by MORTH as the CAFE non-secretariat. ICAT holds the BIS recognition for various components like pneumatic tires, wheel rims, safety glass, and many. So ICAT's facility is under the IMS approval of ISO 9001 and 14001. Facility recognition by CIRO, Scientific and Industrial Research Organization. We have a few certification partners for operating on global scale and for certification for export homologation in India, like Kia Korea, IDIADA, NRCS South Africa, QV, and many. We have some key international MOUs as well for different activities like business development, certification, and joint collaboration activities globally with Kia Korea, MPR International Germany, FT Techno Japan, Qatar China, Milgroup UK, and GulfTech Dubai. What are the services offered by ICAT? Here at ICAT, as we have already seen, the services offered are for type approval as per the CMVR and as per the CPCB norms. We do a lot of testing activity as per global norms like ECE, FMVSS, along with the IS and AS standards that we use in India and various OEM standards as well. We perform a lot of developmental test activity that includes the pre-certification, durability and validation of components, vehicles, and other engine parts, and functional development and validation of components and vehicles. We do a lot of design validation and product validation activity as per the customer specification as well. Again, we are the CAFE Secretariat for 4-wheelers, and we hold the BIS type approval for gensets and wheel rims and safety glass. And we undertake various research and developmental projects as well. Coming to the facilities that we have at ICAT, first we'll go through the facility that are shown on the screen at ICAT Center 1. So it holds the facility for vehicle and engine emissions, which is the vehicle test lab and the engine test lab. And fatigue test lab takes care of the structural durability and integrity of various automotive and non-automotive components. And automotive electrical and electronics lab that takes care of all the testing and validation for automotive vehicles, and alternate fuel ATETC lab that transmission validation and the noise level of the transmission in various vehicles. Some other facilities that we have at Center 1 are the photometry lab, which takes care of the certification and validation of automotive lamps, bulbs, and reflector component test labs for mechanical components like wheel rims or brake hoses or seats or safety belts. CAT CA lab for various simulation and design activity where we do the validation on various simulation softwares, infotronic lab, and alternate field. Now coming to the facilities that we have at ICAT Center 2. Facilities are electromagnetic compatibility lab, the EMC lab, which has the EMC regulations for various automotive and non-automotive parts. Passive safety lab, which houses the crash lab and the pedestrian safety lab, and as well as the sled facility. The NVH lab for noise, harshness, and vibration. Vehicle evaluation lab, which takes care of the vehicle durability and the vehicle level tests, and test tracks where we conduct the vehicle durability tests. It is taken care by the VL department. And tire lab, where we do the certification and development activities for the tires. Now coming to the component test lab. Component test lab, like we have discussed, is for just a minute. Yeah. Like we have discussed, the services offered by the component test lab are the type approval and certification activities for various components that you are seeing on the screen. Some of them are the safety class, hydraulic brake hose, wheel rims, RPMs, door hinges, fuel tank, seats, and many more. Some of the activities that we'll conduct on various of these parts and some other parts like HVAC system and urea tanks, charge air coolers, those are the developmental testing, and we do a lot of developmental testing on seats as well. Coming to the vehicle level certification activity, where we test, some of the tests are done on the complete vehicle, where the vehicle homologation comes into picture. So some of the tests are the anti-theft device testing, pillion handhold testing, spray suppression, seat belt anchorage, and interior fitting tests, as per the standards that are shown on your screens. Some of the major test facilities that are there under the component test lab, now I'll show you on the screen. Like the wheel rim test facility, to your left, you can see the cornering fatigue test facility, radial fatigue test for wheel rims, and below are the reference standards and the maximum bending moment and radial load that we can apply to any component that we are testing here, and the sizes of the wheel rim also. Safety belt test facility, where we do the certification, homologation activities, as well as the developmental activities as per the reference standard given below, 15140 IS standard. Retractor durability, again, the safety belt test facility, retractor durability, buckle durability test rig, and extraction retraction test rig as per the same standard. Now we have here is the seat belt anchorage test facility, where we do the vehicle level certification of this test, seat belt anchorage test, where we check the integrity of the anchorages where the seat belts are mounted on the vehicle body. Basically, it's a structural test that we do here. Fire resistance test facility for plastic fuel tanks, which we have at ICAT Center 2. Where we test the fuel tank capacity under a fire condition, whether there is any leakage or any blast is there. Vibration test facility for various automotive and non-automotive components, where we do a lot of tests as per the GIS, IEC, and other OEM standards. Some unique facilities that we have here is for the coolants and the charge air coolers, where we test the thermal cycle for the radiators and for the internal corrosion in the coolant cases. Below are the parameters and ranges that are given, which we can operate. A lot of environmental test facility are there, like chambers of various sizes and temperature ranges that we can actually operate for various automotive and non-automotive components. Some of them are like weatherometer, thermal cycle chamber, humidity chamber, walk-in chamber, salt spray chamber, etc. Now coming to the bottom line, the ICAT facilities that we have for seats. What services do we offer here for the seat homologation or development and environmental testing? First of all, as per the NABL guideline, we have accredited by the NABL for IS 15546 and AS 023 standards for testing. And we do here a lot of Indian homologation activities and developmental activities of various OEMs and other seat manufacturers as per their own standards. And we can do a lot of strain gauging activities and data acquisition for various durabilities or any temperature conditioning for seat. Now coming to the applicable test standards that are there for seat testing that exists in India as well as globally. So first we'll go through the Indian standards. The standard like IS 15546, it is for the M1 category for front and rear row passenger seats, and AS 23 for other than M1 category vehicles, mainly for buses and trucks. And as per the safety standard AS 160, which support the seat testing as a safety standard for construction, that are ISO 11112, ISO 6683 and 7096, which are basically for the operator seats. And coming to the international standards that are there for the seat level testing, VCR 17, VCR 25, FMVSS 202A, FMVSS 207, and various other global standards. As per the vehicle category, this slide shows you what are the regulatory required for vehicle category wise. So first, like we see here, M1 category, as per IS 15546, we have tests like dimensional measurement test, headrest performance test, energy dissipation test, and seat back strength test. So for your information, as per the standard, if we complete the headrest performance test, the seat back strength test is deemed to be met. So if somebody completes these three tests, dimensional measurement, energy dissipation, and headrest performance, and if the criteria of headrest performance test is met, the seat back strength for the seats are not required. And then coming to the other category, other than M1 category, which is taken care by AS 23 standard. So few tests here are similar to that of the M1 category, which are applicable for the driver and the front passenger seats. That are the dimensional measurement, headrest performance, energy dissipation, and seat back strength, as and when required. And coming to the passenger seats of the buses, we have requirements for dimensional measurement, static strength of seats, and energy dissipation. There we do not require the headrest performance test and seat back strength test. Now, talking about the construction equipment vehicles, there we have 4 tests: the dimensional measurement test, evaluation of operator seat vibration, and SIP measurement, and seatbelt anchorage test. So these are the tests that are applicable on the seat level. Now we'll have a glance at the pictures of the test facilities for seats that we have at ICAT. On to your left, we have the seat back strength and headrest performance test rig. The reference standard here as per IS 15546, and the maximum moment that we can apply on the seat back is around 630 Newton meter. Depends on the seat configuration, obviously. And interior fitting test rig, where we do the impact on the headrest in area 1, area 2, and area 3, as and when applicable. and check what is the deceleration value and whether it is meeting the regulatory requirement. We can go up to a speed of 32 km/h, whereas the standard commands for 21 km/h. Now on to the left again, we have the seat static strength test rate, which are applicable for the buses. If you remember on the previous slide, as per AS23, where we apply the torso and pelvic region loads on the seat back, simulating the rear passenger giving a load on the front seats, and check the displacement as per the regulatory requirement. On your right, we have the static seat anchorage test, which we do on the passenger seat level structures, structures representing the seats. We apply the load at a specific height as per the regulatory requirement, and the pull as per the pull load is as per the seating capacity. To your left, again, we have seat anchorage test facility. Now it's dynamic. These are performed on the front passenger and driver seats, and these have like forward and rearward direction sled, and where we do the impact seat, keeping the seat in a forward direction and then keeping in the rearward direction to simulate forward and rearward crash scenarios, and in different seat configurations. On to your right, we have the SIJ 826 3D mannequin, which we use for the edge point measurement of the seats. This is a very basic dimensional measurement that we have on the seats for almost all the requirements. Now coming to other developmental facilities that we have at ICAT and which we have done in the past for various customers, like you see, hysteresis loss on the seat cushion, on the seat back cushion, suspension test for operator seats of construction equipment vehicle or maybe the metro seats, seat strength test for the seat structure level application, cushion frame edge strength, where we check whether there is any deformation in the frame of the cushion during the loading or after the loading, and seat damping test, armrest operation load test, armrest displacement test, and horizontal strength test of armrest. Here we have the photos of seat durability test on the mass multi-axis simulation table that we have here, where we collect the road load data and feed the road load data to the system, and mark the damaging data and run the number of cycles to simulate the damaging cycles that the seat can suffer during its life cycle. It's basically an accelerated life cycle test. On the center, you see the airbag deployment test for seats. So we do a lot of airbag deployment activities on seat as a component. And on to your right again, normal vibration test for operator seats of metro rail. Now, here we have an announcement to make. So like you can see, these are some upcoming events that we have here at ICAT. On the backdrop of safety, we are pleased to inform our audience that ICAT, in association with SAE NIS, is organizing a seminar on improvement of automotive road safety and vehicle fire incidents on 6th of June 2023, in the next month. This seminar aims to bring together stakeholders from the vehicle and road safety domain to share their knowledge and experiences and to showcase the advancements made in the field of automotive road safety and vehicle fire analysis and suppression. With the rapid rise of road crashes and the vehicle fire incidents in India, this event shall highlight the road safety needs and adequate roadmap for Indian scenarios. The registration for this seminar is now open, and you may contact us or the details as shown on the screen. You can note it down. I'll pause it for a moment. and you can register here. So we would like to request you all to be the participant in this seminar and gather knowledge and contribute towards road safety. Thank you all. Thanks a lot. I'll keep this slide on pause. I'll ask the host to actually keep this slide on pause so that you all can note down the details. Thank you all. Thanks a lot.
Thank you so much for the excellent presentation, sir. Moving on to the last presentation of the topic of aircraft seating and its challenges, I would like to invite and introduce Sri Srikanth Rao. Sri Srikanth Rao is working as a senior principal engineer in mechanical design team at Collins Aerospace. He has over 18 years of vast experience in product design and development, manufacturing, and prototyping. He has completed his master's in product design from Nanyang Technological University, Singapore. His current research interests include product design, design for additive manufacturing, mechatronics, and design for manufacturing and assembly. He currently holds over 14 patents. We welcome you, sir. You may start with your presentation now.
Thanks a lot. Thanks for the introduction. Very well, warm welcome for all the participants. Thank you for this opportunity. I would like to thank ICAT for giving this platform to share some of the nuances of aircraft seating, which is pretty interesting topic, and some of the challenges in that. Let me share my screen. Let me know if you guys can see my screen. Can you guys see my screen?
Yes, sir.
Okay. So before I even talk about the aircraft seating, I would like to introduce Collins Aerospace, a company. So the Collins Aerospace is an aerospace company which is the leader, I would say, in all the major aircraft. You can take it like military aircrafts or even passenger aircraft. So a lot of aircraft components are manufactured by Collins Aerospace. Almost, I would say, the engine, the landing gear, the fuselage, the aircraft seats, interiors, the water, the lighting, evacuation systems, you name it. So you have almost all the components coming in. So we are kind of pioneers in that. So it has got multiple a legacy of innovation, I would say. So just a minute. Can you guys see my screen? I'm not able to. Okay. So it has got multiple areas of innovation. We got avionics and communications, which was invented by Arthur Collins. Electric systems by Davidson Strand. So Hamilton, I believe you would have heard of Hamilton and Strand. So that's where it's coming from. The landing by Goodrich, nacelles by Federer, and then the propeller system by Ratio. So this is a very, I would say, an innovative company. Till now, we are kind of inventing a lot of stuff which kind of flies in the plane. So we got multiple strategic business units. We have advanced structures. So a lot of testing capabilities were shared by ICAT. I think most of the testing will also be applicable for aerospace as well. So if you take avionics, we have to do the EMI testing. There's a lot of opportunities where we can collaborate and work. So these are some of the BUs. Like we have advanced structures. We have avionics, the connected aviation solutions. And then we have the interiors. So I'll be talking about this particular BU now. Under interiors, we have aircraft seating, so which I'll be talking about. as well, and then the mission systems, which will be major, from military standpoint, and also some of the ejection seats, which we have worked on mission systems, and then power and controls, the battery management, and also the electric systems. So typically these are the strategic business units which Collins Aerospace has, and we have a big division in Bangalore. So there are some 4 to 5 plants. One is in Hyderabad, including that it's 5. So we are working mainly on providing basically design, research, and also manufacturing and assembly. So this is what the India team is helping out Collins Aerospace. So when I talk about aircraft seating, so it can be classified into major 2 sectors. One is fixed seats, other is the ejection seats. The fixed seats are basically all the passenger seatings we see, the crew seats, all those come under fixed seating. And there is something called as ejection seats. So these ejection seats go into the fighter jets, where the seat has to be ejected under certain emergency cases, where the pilot has to, in order to safeguard his life, he has to eject out. So those are ejection seats. Today's talk, I will mainly focus on fixed seating because that is very comparable to the automotive seats. They are very much comparable, but there are few differences. But overall, you can say, you can take a benchmark on an automotive seat. So the fixed seating, we have basically the fixed wing. So there is something called as fixed wing is our normal airplanes, and we have rotorcraft seating. Rotorcraft seating is your helicopter seats, and also the VTOL. Now we got a lot of vertical takeoff lift, aircraft which are coming in. So those are all rotorcraft. So the requirements are different for both of them. I'll be talking about it a little later. So the fixed wing has got this passenger seating, which has got the first class business seats, the premium economy seats, and then economy seats. And then similarly, you have crew seats where you have pilot, co-pilot, cabin attendant, and observer seats. Under rotorcraft, you've got helicopter seating and then the attendant seats, because some of the medical attendants during some emergency where planes are not accessible under high altitudes, so they use medical helicopters. So it's called a medical ambulance, and then they have a medical attendant seat for that, and it has to have certain requirements and certain features. So those seats as well we make. So those are very niche seats. So when you talk about the volume, so we make a very complex, ejection seats, first class seats. It has got multiple mechanisms. It has got a lot of features. It has got an inbuilt heater, the massager, you name it. So a lot of features are there in the first class seats. And then we have, so as the complexity goes down, you can see, the crew seats, the cabin attendant seats. Maybe you would have traveled, you could have seen some of the, wall-mounted cabin attendant seats. So we make them as well. So based on the production, the passenger seats wins. Based on the complexity, the ejection seat wins. So this is the overall portfolio of what Collins Aerospace does from seating standpoint, and every seat is different. A business class seat is totally different than a VIP business jet seat. So it has got a 0G position in a VIP business jet seat. The 0G position is not there in some of the business class seats. So there's a lot of nuances for each seat, but this is how it is kind of laid out, and every seat we kind of manufacture and produce in Collins Aerospace. If you take an aircraft map, so this is, it's called seat map or a LOPA. So if you see this, these are some of the first class seats we have, and this will be your economy or premium economy seats, and rest all is passenger seating. So based on the volume, passenger seats a lot. Next comes the premium economy seats, and next comes your first class seats or the business class seats. This is how a typical aircraft has got this seats laid out. So overall, if you take let's say A350, it has over 440 seats, 440 passenger seats. which we do, and look at the volume of one aircraft, and that's where the manufacturing process selection, the material selection, all those matter a lot when we come to passenger seating. So this is a typical crew seat. So we have got a wide portfolio of crew seats we manufacture, and they are basically classified as a floor mounted seat. The floor mounted seat can be either a track mounted or a hard point mounted, like our car seats. So these are the various portfolios. We have a simple cabinet seat to a high comfort cabinet seat based on the hour of journey the airliner will take. How many high comfort seats you want. So high comfort seat will have a recline feature, will have a leg rest deployment. All these mechanisms are built inside the seat to cater that. And the wall mounted seats are basically mounted onto the cabin wall or onto the lavatory sides. So those are much from testing standpoint, the floor point mounted seats are very difficult to pass because it's a big long cantilever which gets attached onto the floor, and the 16G and the 30G testing which takes a lot of beating, and we have to make the structure strong enough to take those impacts. Whereas the wall mounted seats is attached to the wall, and a lot of load is taken by the wall, and they can be optimized further. So the design philosophy will change based on the way you mount the seats. These are some of the pilot seats we do. So the pilot seat, will have a lot of features, which has got headrest movement, thigh support, and also some of the powered seats, like you can lift and recline a little bit with this. So we do a lot of pilot seats which are there, and then these pilot seats go for a lot of Bombardier, Embraer, a shorter aircraft, and also for the A350, A320 larger aircrafts as well. So we make a lot of pilot seats which gets into the cockpit of the aircraft. So this is a business jet seat. It's a Cessna business jet seat. We have this has multiple features. This is the zero gravity position I was talking about. So this zero gravity position will be a very relaxing position for the occupant, where they are paid a lot of money. So it's a very expensive furniture, I would say, in an aircraft, if you want to name it as a furniture. So this, apart from all the luxury comforts, you can see how the leg rest has been deployed, everything with the actuators, and has got an inbuilt heater and a massager to it. So this particular thing, seat has to go through a lot of testing. In order to make it flight worthy, we have to ensure it has passed 16G, 14G, 24G, multiple testing which gets into in order to make the seat work because of its, and this is getting mounted onto the aircraft. We have to do salt and fog testing, which is an environmental test, the vibration testing. So a lot of design challenges are, we need to take into consideration for designing such business jet seats. And this is a typical helicopter seat. So these helicopter seats will have an inbuilt energy absorbers as well, because when this helicopter crashes onto its belly, a lot of impact is generated and goes to the occupant. So we need an energy absorber which is designed. So currently the helicopter seats have got a wire bender type of energy absorber. That itself is a patented technology on how it can take these impact loads and ensure occupant safety. So occupant safety is extremely critical in all these seats. So the helicopter seats are typically equipped with a wire bender type of energy absorber for energy absorption. So those are some of the unique. So if you look into it, every seat is different, and the design philosophy is also different for these seats. These are some of the premium economy seats, and this is a passenger seat meridian seating, and this is the MIQ seat. So these are the passenger seating doesn't have much of the features. All it has is the armrest and little recline, and it has got basically the headrest also you don't have much control over there. So it's like a stool. If you consider aircraft automotive as a seat, this is more like a stool. You have to just go and sit and very little recline. And this is a premium economy seat where it has got a little more better comfort than the passenger seating. So you have a better recline, you have the leg rest. So I mean, the amount you pay, that's the comfort you get. So it's a different portfolio. We got larger number of economy seats, lesser number of premium economy seats, and even lesser number for first class seating. So these are the various seats we saw, from right from passenger to helicopter seating. These are all fixed seats. And the challenges we talk about. So the main challenges we see here in aircraft seating is when we do the testing, we have to warp the floor. So the floor of the aircraft gets warped because under emergency case. So in order to simulate that, we have to do the sled testing with the warped seat. So the seat is warped means it will be, let's say it is mounted on 2 tracks. One of the tracks will be pitched down and the other track will be rolled. So this is already deformed, pre-stressed. So this pre-stressed seat will be running under the sled for, let's say, 24G or 16G, and it has to pass. So it's already deformed. So we have to deform it to begin the testing. So a lot of design consideration has to be taken. So to cater that, we rely much on the, some of the LS Dyna simulations. So we do a lot of LS Dyna simulations before we actually go out and test, because testing is a very, very expensive process, and it will be the last thing to certify the seat. So before all this, we have to do a lot of iterations for the material, because let's say we have used more composites, and the composites will not allow the part to deform. So they are very, very rigid and stiff components. So where to use composites, how to ensure the, it is warped, the floor warpage, whether any mechanism can be developed for warpage isolation. So those are some of the things which is taken into consideration when we start doing the testing. And the head impact criteria, this HIC is a very important value, because it has to be less than 1000 is what the requirement is. And under emergency, when there's a crash, the occupant will go and hit on the front seat. There's no airbags. Just like in automotive, you have airbags, which will basically reduce the HIC. There's no airbag as such here. So all the restraint. So the main difference also between automotive seat and aircraft seat is you have the restraints. Those restraints go to the car body or chassis, where the structure where your restraints are mounted onto, or the occupant is getting into. But in some of the aircraft seating, the seat will take the restraint. So the aircraft, the seat itself will have the restraint, and the whole seat has to take the load. It's like a big cantilever, and you have got 3 occupants in one. 3 occupants with 2 legs. So the 2 legs has to take almost like 170 pounds into 3. So that many load, almost like 700 pounds into 30G. So that much amount of load it has to take under under dynamic situations. So that is the challenge we see in the aircraft seating. And if you see the portfolio of seating, what we are testing, what we do, we have to do all this static testing all the way ranging from 2G up to 9G. So we have to do a lot of forward, sideward, downward, you name it. So you have multiple ways the static testing is done on the seat to ensure that it is within the elastic limits and it won't plastically deform. And it can plastically deform only under dynamic cases.